Okay, now we're going to look at section 5. That is for change detection with bulk and dynamic world. So the dynamic world project brings in every Sentinel-2 image into a neural network that's been trained on millions, I think, millions of images. And so what they intend to do with that is to create a near real-time classification of land use and land cover on Earth's surface, and that is kept continually up to date. But as we've seen, if you look at an individual pixel, there are always inconsistencies from day to day to day when we look at their stated land use and land cover. So thinking about the idea of the events that we saw in the earlier sections of this lab, we know that some pixels will change and be more likely to change than other pixels. And so what we propose to do here, and what we'll do in this lab, is to use bulk to explore those classifications and refine them. So we're going to go back to code checkpoint F48B, and we will set it for dynamic world. All right, so I'm going to go to F48B, which is the bulk interface, and I will load it again, I suppose. So it should say bulk interface current at the top. And now if I run that, or you can go back to your older tab if you still have a tab open for regular bulk. And I'll let go of that. And this time we will select dynamic world. So we select dynamic world, and we are going to now study it in the same approximate area. I'll triple click on that to grab that place, because dynamic world exists everywhere on Earth. So we could ask for any place on Earth using a polygon like this. We can do that anywhere. Again, we had that idea of remapping images. We'll come back to that in just a minute. And now here it says, well, which year do we care about? 2021, day 150 to day 300. So let's go do that. 2021, day 150 to 300. All right, and if you've looked ahead, you see that it says put in number 9 for the classes of events and the number of classes to track. That should already be set. And now we'll go down here to where the color output palette is. And we have reproduced the palette that is recommended for dynamic world by that group. And we'll paste that in here, hit tab so that it's taken in. You'll see it turn to green when it's taken in. And when it's finished, we'll hit apply parameters. So we'll do that and hit apply parameters. And what that will do is move through all of the images from day 150 to day 300 of the year 2021 for this area. And that shows us here, same type of information that we peeked at for the other part. It shows us this land cover classification synthesized through time, and happens to show us the last one. That's what we're showing as the default in that particular panel. Here's the legend, and so we can compare a little bit. So this light green is grass. We can predict that that is probably used as agriculture, but the land cover, separate from the land use, the land cover is that it's grass. Now, there's also a category called crops, and so that maybe can make us think that this grass is actually pasture for cattle, perhaps. Here's a forest category, that's this blue, or green, sorry. And so crops and shrub and scrub, this orange and beige colors, are those. And so let's go, and we'll go to a particular place, which we've already kind of been to with this video, but we'll enter that place and then click on the place. That will zoom in or show us this area. right. And that shows us the results around there. We can make a movie of the results. I'll just show you here. I believe that we produce a little movie of the events over here on the right. So here are the events that produce it. They're drawn with some speed, maybe 5 images per second. And so as you look, you can see some places are classified as red. That was called urban. Among these events between days 150 and 300 of the year 2021. But it's hard to tell. We can see pretty well, here it's called urban several times over in this area, but it isn't, we don't know for sure what it is called in the bulk interpretation of this area. So that's something we can go look at. We're going to now zoom in to this town, and we'll come back and look at this confidence. Here you can see the confidence value changing through time. And so as we receive more evidence in a particular place, some pixels we become more confident in their class. Other pixels, if they're moving back and forth between different categories, we maybe become less and less confident that they are one class and not some other class. So it depends on the land use history or land cover history in every pixel. And the land cover history in every pixel is what is given to us by Dynamic World with these events. And so our challenge is to figure out a map from those events. So we'll go up here. We will go to the bulk movie. That's going to show this same image there, but a little faster. I think we suggest to set it to 6 at a medium resolution and draw the thumbnail. So it takes a minute for that to draw. This is designed for me to be able to move over here to then get to the right same size, however we want. All right. And so here you can see bulks changing interpretation. Blue means I have no idea. Then as we get more and more information, it develops a stronger and stronger, typically, it develops a stronger and stronger sense. And then at some point there's a last day, and that's the day before that blue frame that just showed up. And so this is the estimate for bulk of these classes. Now, if I go to the inspector and I click on one of these pixels in the middle where it's hard to really fully understand, and it's called a lot of different things during the year, I'll click on it up here, see if we maybe get one of those pixels that changes a lot. All right. So here in the Sentinel-2 dynamic world, you can see this pixel is called class 3 for a bunch of the time, then class 6 for a bunch of the time, then class 3 again for the rest of the time. Bulk begins with the estimate that it's class 1. I think that's the initialization. And then soon after changes it to be class 4 or 3. And then for as long as the system is insisting with real steady statements that it's class 6, bulk will follow along. And then, however, when it changes back to class 3, bulk will bet that it's still class 6 for a little while and then change back to 3. So this pixel would appear to be one that we're not so confident in a way. If I go down here, you can probably see, here's the confidence changing in that pixel, where we thought it was one thing, and then we started getting evidence that it was something else. And so our probability, our confidence changed to be lower. But then as it was called 6 again and again, our confidence slowly grew until it was just as confident that it's 6 as it used to be that it was 3. That's why these two elevations of the confidence chart are the same. But then we started getting more statements that it was 3, and again and again and again. Well, first, our confidence dropped that we were our general confidence about the pixel fell. Not to zero, because it's still, some classes kind of still the champion, but then over the next few images, our confidence then grew to be kind of its maximum setting, which is set to be about 90% with those particular levers that we looked at before. And so we can see that same kind of thing if we were to look over here at the confidence and look at a movie of that confidence here at 6 frames per second, and see it as medium granularity, and we'll see what it shows. And so what that thumbnail shows us, this is a thumbnail of the confidence, remember. What it shows us is, let's look over here, the easy place. It's always called forest every day. We begin with approximately 100% confidence that it's forest. I guess it's 90. And there's no real reason to change because it's called forest every day. Other pixels change back and forth a lot. So here you can see some of them change altogether. Others change a little bit at a time for reasons that are confusing to me. And yet bulk is asked to tell us what's the most probable land cover at every moment, but also what's the most probable confidence at every moment. And so if we go back to the code here, or sorry, to the manuscript, we can see here's the inspector tab, same type of thing. There's the confidence we can view off to the side. Here I just did a screen capture of one of the frames that you just saw. And that's the idea of that. But let's imagine like we might see, you might think, yeah, but what if I really am looking for loss of forest versus not loss of forest? What if the category of grass or shrub or scrub or crops, what if those are all kind of equal to me? And that is what we're able to do by changing the classification by remapping. So what I'm going to do is I'll go here and copy these numbers, the 0 through 8, come back and put them over here under remap images. Got to make this panel bigger again. I'll say, I want those numbers that are 0 to 8, and I want you to reconsider them. I've looked at the legend, and what I want is I want them to be numbered like this: 1, 0, 2, 2, 2, 2, 2, and 0. They're that's the same idea as when I mentioned the forest and water and human are 1, 2, and 3. Here they're going to be numbered 0, 1, and 2. It's just how we decided to number them this time, but it's the same idea. Forest is this lowest number, 0, and then water, there's just one of them, it's the first one, and then all the rest in our experience of looking closer at this area are agriculture of some sort. And so now I need to change a few other things. I'm not tracking 9 parameters anymore. Or classes, I'm tracking just 3. So I'm tracking just 3 of those classes. I forget, maybe we'll change the probability set. No, or the levers, we'll leave the levers the same. And I'll grab the palette and put that palette here because that was a 9-color, 8 or 9 color palette. We just want a 3-color palette. Hit tab to take it. And now go back to make sure there isn't anything else there. We've set the number of classes, that's all 3. And now we hit apply and look to see what the results are. So I'll go back and make this small. And if we zoom in, now we can see, if you think about the whole arc of this lab, now we can see how bulk can be used to do that same interpretation that we did at the beginning of the lab. So at the beginning of the lab, the user, my lab, needed to make a classification for every image that we could find. We did that, and it took a really long time. Here, we're able to let the dynamic world classification produce these images for us. And then we will use bulk to sift through those images and look to see. I think this is the area where we were. Oh no, it's still up here. We'll just go to that same spot and draw it. Now here's that same spot. You remember it had a lot of different colors on the previous run. But from the perspective of just forest and water and apparent human, we can see that we're actually not unconfident, probably, in this result. Here, I'll turn on the confidence layer. And this shows us that for the most part, we're actually very confident in all of the pixels, except at the edges of the forest, from the perspective of forest and water and human. So to have a deforested or not deforested map, we're very confident in the pieces in between. And there are definitely some places where, for whatever reason, this is called forest almost all the time, but maybe not all the time. And this over here, I think, is called agriculture, or the highest category, number 2 or number 3, but not all the time. But mostly, almost all of our uncertainty about this landscape is cleaned up when we reconsider what the classes are. Now, this is really hard to do outside of a program like this. If you remember back, we had here in the console, we're just taking in images that look like this. And this really noisy image, or really noisy image collection. And so those little sort of angled stripes are where they remove clouds. They're very aggressive about removing clouds. And here you can see, if we ask for the bulk movie, change that to go a little faster, set that to medium, and redraw the thumbnail, you should be able to see the same kind of thing where it starts off blue, I suppose, and then we'll see how long it takes for it to become confident of those particular classes. So you saw it start with all the same image, and then soon after grew its understanding of the landscape very quickly, after probably just 4 or 5 or 6 classes, or 4 or 5 or 6 images. I think if I was going to look further at this system, I would say, well, this is pretty strange over here. Maybe it's just noise, but something in the confidence map tells us that something might be unusual over here, and it might be worth investigating. We could then maybe use the other program, bulk D, to go and look to see what these numbers are, what the NBR values are in these pixels compared to what we saw in the other pixels. And so that is the idea of how we move through this distinction between the raw data that we get from all of the classes, which that's the job of dynamic world. But it's really hard to interpret all of that for every purpose. So what we think is possible is you can come here and reinterpret, remap those categories for your own purposes by changing them around up here. If you'd like, you could set one category to be 5, meaning I don't know what this is, or 5, meaning it's an emergency, I need to look at it, perhaps. You can run it for any time. You can also run it if we want. We could change it. Can't remember for sure how this will work. If I change it to 2023, I'm recording this video in 2023. But day 150 has not arrived yet. So we'll change this to be 1. And when I record this, we just finished day 90 of this year. And so if I hit apply parameters, let's see what it gives. Okay, and it gives an image of the landscape that's still pretty uncertain. So if you remember, what we saw with the movie is that we began with the initialization just in order to get it to run. We initialized it to be all green, all forest. Of course, you could initialize it to be one of the images. So one of the choices here over on the left is the initialization approach. We have the ability to put in a particular image as the first image for the initialization approach. And that would allow us to tune the beginning so that it began with our best expectation, because we know from other work that this area has changed. So the overall idea of this whole lab is that, you remember I went from 2000 to 2016, or made a map of 2016 in the paper that presented bulk. We then went from 2016 to 2020 using events that we ourselves have classified. Then for this last piece, we took the dynamic world classification, and we have the ability to bring in hundreds of classifications that are automatically created by the same program. So in a way, by the same user. So they should be similar to each other. And we then can sift through them looking for information. And so that's to finish this lab. We then show at the very end, we show the confidence layer from the first run with all of its noise, because there were 8 categories. And without remapping over here, this is zoomed way in, so it kind of exaggerates, I think, the differences. And so that's what it shows. Then at the very end, we have some synthesis questions that you might do in order to move to a few different places, run it in some location. Here you can ask also run it for 2021 and 2022. So with that, I'll say thanks for following through this video. And I really appreciate your time, and I hope this has turned out to be interesting. Thanks.